in this session, we're going to talk a little bit about system curves. And system curves are really a graphical display of the resistance that the system offers to the pump. So if we look at a system curve, it's going to consist of flow in this direction, and it's going to consist of head in this direction. And the system resistance curve is made up of two basic components. There's going to be a static head component. Can you see that? And there's going to be a friction component. The static head component is simply expressed by the difference between the surface level of the suction reserve and the level in the discharge reserve. So it's just a static head differential between one surface and the other. And usually the delivery point is higher than the suction point. Okay? So, and that is usually measured at zero, or it's defined at zero flow. So there might be a static head, which is fixed, which is the differential between, as I say, the surface of the liquid on the suction side and the surface of the liquid on the discharge side. The system can be of two types. It can be an open loop system, and it can be a closed loop system. In a closed loop system, the static suction head is identical to the static discharge head. So HS in a closed loop system is zero. So your starting point is here. In an open loop system, it's the differential between the surfaces, and that can be anything from zero to the geography of the location that you're working. Okay? So that's our static situation. Our total dynamic head, which the system curve is trying to project, is the combination of the static head plus the friction losses in the pipework. Now, the friction losses in the pipework are dependent on, first of all, the pipe material, the pipe internal diameter, and the overall pipe length. And all of these will vary from system to system. So for every system, you have to draw a unique system curve. Okay? So if we draw a system and we make an assumption about the diameter of the pipe, the length of the pipe, the number of bends, we should be able to calculate the friction losses in the pipe system, and that will basically be a square law curve. So we start at the static level and we go to the maximum flow condition, and that will give us the system resistance, again, measured in meters. So if you use friction loss tables, and there are plenty of different organisations that provide those, you can work out what the friction losses are for a particular system. So when you're going to choose a pump to match this system, and remember the pump will always perform where its curve intersects the system curve. It's a basic parameter of pumping laws of physics. So if we put a pump curve in, and we'll take a maximum diameter of a particular pump, that is the HQ curve for the pump, and this is the system curve. The pump will operate at this point where the pump curve and the system curve intersects. If your client tells you he wants, let's say, 50 litres a second, and he says that I want a pressure of 50 kPa, unfortunately, you can't guarantee that. If you specify 50 litres per second, and this is your system curve, the pump will develop only enough pressure to overcome the system resistance. So artificially expressing a requirement for pump pressure is the wrong approach. You've got to work out your system losses, where the intersection point is the pump will only produce enough pressure to overcome the system resistance. Okay? What happens if you calculate the system incorrectly? Anybody got any ideas? Okay, well, let's have a look. If we calculate the system incorrectly, and this was our theoretical, but our actual system curve is more like that, where will the pump operate? The pump will operate here. And that could be right at the end of the curve. And in this situation, the pump will be operating very unhappily. Okay? It's not a preferred operating zone for the pump. You will get vibration, you will get noise, you will get premature component failure. That is the inevitable outcome of operating a pump too far to the right of best efficiency. If we overcalculated the system resistance, we could get a different curve that looks much more like that. This is larger pipework, this is smaller pipework perhaps. And then we will get a lower flow, and we will only get 30 litres a second, but at a much higher pressure. So only when you know what the system is going to be can you correctly select the pump. It's not an arbitrary selection process. You have to know what your system conditions are before you can properly select the pump.